So hello everyone, today we are back with another problem and today we're going to be looking at algebra. We are going to be looking at some properties of logarithms and logarithmic equations, and I have a problem for you from the AMC. So let's get started. This is problem number 10 from the AMC 12A conducted in 2020. And in this video we are going to be looking at certain properties of logarithms. We're going to be solving a logarithmic equation using properties of logs. And then we have certain book sessions of the AMC, and at the end we have a similar but challenging problem.
This video is sponsored by Cheenta.com. Since 2010, Cheenta has trained thousands of students from all around the world in mathematical Olympiads, physics Olympiads, computer science and informatics Olympiads, ISI CMI entrances, and research projects for school and college students.
So yeah, before going to the problem, I'm just going to review some of the properties of logarithms. Now, log is nothing but another way to write an exponent, right? So you must have seen a raised to the power b is equal to c, right? And if you just take the logarithm on both sides, you'll get b log a is equal to log c, right? So b can be basically written as log c to the base a. This is kind of the concept. And if you have log c to the base a written as b, then you can basically write a raised to the power b is equal to c. So these two are equivalent expressions. You can consider that they are equivalent expressions. Okay, and then obviously we have some properties of logs. Log 1 is 0, log to the same base is 1. You have the product rule, the quotient rule, the power rule, the change of base rule. We have the equality rule, which is really quite obvious, and you have certain other rules. So really the more important ones are the product rule, the quotient rule, and the power rule, as they are used the most in questions. And yeah, once you've just gone through this, we can start away with the problem. And this is just a simple problem using certain properties of logs that if you know about would be great. And they're asking us to find a unique positive integer n such that it satisfies the given equation, and then find out the sum of digits of n. So we really need to find out n, right? So we have log to the base 2 on one side of the equation, and we have log to the base 4 on the other side. So we can just really convert both of these into log to the base 2. That would be great, right? So this can be basically written as half of log to the base 2 times log n to the base 4. And I can really send half to the other side. So we have this thing over here, and over here we have log 2 of log n to the base 4. Okay, perfect. And this 2 can be sent up. So this becomes log n to the base 16 whole squared is equal to log 2, and we have log n to the base 4. Okay, so log a is equal to log b. That basically means that a is equal to b, as we have studied from the equality rule. So that basically means that log n to the base 16 whole squared is going to be equal to log n to the base 4. Now I can basically write this as 1/2 of log n to the base 4 whole squared is equal to log n to the base 4. And now I can really do something. I can take log n to the base 4 as t. So this gives me t by 2 whole squared is equal to t. In other words, t squared by 4 is equal to t. And we can really see that t squared is 4t. Now we have obviously two solutions. We can just bring 4t to the other side and factorize this. So t minus 4 is equal to 0. So we have two solutions, t is equal to 0 and t is equal to 4. Now, if you actually notice this logarithm, right, log n to the base 4 can never be 0, right? Because if it is 0, then that would have to mean 4 raised to the power 0 is equal to n. And we can see that no such n exists, right? Because 4 raised to the power 0 is always going to be 1, right? So it really does not exist. So we need to find, basically, the 0 is eliminated, right? So t is equal to 4 is the only possible solution. So log n to the base 4 has to be equal to 4, right? So n has to be 4 raised to the power 4, and therefore n is 64 times 4, which is 256. And therefore the sum of digits of n is 2 plus 5 plus 6, which is nothing but 13. And therefore our correct answer is 13. That was a pretty simple question. All we really needed there was certain properties of logs, and obviously the power rule and the equality of logs. These two rules are pretty important. And yeah, I hope you enjoyed that. We have some book suggestions for the AMC. We have Mathematics Can Be Fun by Yakov Perelman. We have Mathematical Circles, the Russian Experiments. We have Algebra Can Be Fun, again by Yakov Perelman. We have An Excursion in Mathematics, and we have The Challenges and Thrills of Pre-College Mathematics. And after you've gone through that problem, we have another similar but challenging problem for you. And we need to determine the value of AB if A and B satisfy these two given equations, right? And it's really, again you need to use properties. Let me just remind you of some of the more important properties again, right? So the first important property we had was that if log b to the base a is n, then that basically means a raised to the power n is equal to b. The second one was basically the product rule, log ab is log a plus log b. The third one, as you may know, is the quotient rule, log a by b is log a minus log b. And the fourth one is the power rule. So log, if you have to the base a, let's say b raised to the power n, then this can be written as n times log b base a. So this is really 4 major rules of logarithms, the 4 main, the big 4. Other than that, obviously we have the base change formula and certain other rules, but you wouldn't need a lot of them to solve this question basically, right? So determine the value of AB, and if you thoroughly have known the properties of logarithms, I'm sure you'll be able to solve it. And if you make any progress on this question or have solved it, please let me know in the comment section and I'll be sure to respond to you. Until then, that's it from me, and I'll see you very soon in the next video. Bye-bye.
The programs are designed for students who are passionate about mathematics, and they are personalized with one-on-one training, individual evaluation, and remedial sessions. The reason Cheenta students are successful over the last 10 years because they are taught by mathematicians and real Olympiads from leading universities in India, United States, and Europe. Some of our students come back to teach at Cheenta from Oxford, Cambridge, Harvard, MIT, UCLA, ISI, CMI, IITs, TIFR, and IISc. For more information, visit cheenta.com.